So to this point, we've pretty much ignored transition metals, the middle part of the periodic table, in talking about ionic compounds and ions. We've only looked at S&P block metals as cations. And the reason we've done that is because it's kind of difficult to predict the charges of most of the transition metals. So it says here most transition metals can have several different charges, in fact, so they vary. So not only are they hard to predict just by looking at where they sit on the periodic table, but they can vary in many cases, and actually the same element, the same metal, can have more than one possible charge. So first of all, what are the transition metals? If you get out your paper periodic table and kind of mark it up a little bit here, you can outline, make this nice and big here, we can outline pretty much the D block, and then over all the way to the metalloids over here in the P block, and those are our transition metals. These guys, in many cases, in most cases, can have more than one possible charge. So how do we deal with that? For example, how do we know what charge iron, sitting right there at the top of the transition metals, how do we figure out how much charge it has? Well, it turns out that iron can either be +2 or +3. And we don't know just by looking at the name iron which one it's going to be. We have to include the charge in the name. So for example, iron 2 chloride means that Roman numeral, and if you're not familiar with Roman numerals, you will need to use about the first 6 or 7 Roman numerals. But that first Roman numeral, the Roman numeral after iron, 2, means this is iron with a 2+ charge. That's what it's telling us. It's not that it has two irons, or that there are 2 irons in the formula, but rather that it has a 2+ charge. So if I write the formula for this and I'm being told that it's iron 2+, and again I'm being told that by the Roman numeral, I always know that chloride's charge is 1-. So then I can just use the least common multiple, which would be 2, to figure out the formula, and it would be FeCl2, right? So that we balance the charges out. But again, I could only do this because I was given the information that this iron, this particular iron, has a 2+ charge. So if I have iron 3 chloride, that just means Fe with a 3+ charge. Again, the Roman numeral is not the number of irons, it's the charge of the iron. And then chloride, of course, always has a -1 charge. And so we just have to even out the charges, and this time I'm going to have 3 chlorides. Now, there are some metals that don't vary in charge that are in the transition metal area of the periodic table. You don't have to memorize these, but they are silver, which is always +1, cadmium and zinc are always +2, aluminum, gallium, and indium, and technically aluminum is not a transition metal, but it'll make sense to you in a second when you see where they sit on the periodic table. These are always +3. So for these, you don't give a Roman numeral, all right? So for example, if I gave you the formula AgCl, this is silver with a 1+ charge, but I don't put that in the name because silver always has a 1+ charge. So you would just call this silver chloride because silver is always +1. All right, so we don't include a Roman numeral. If you look at where these guys sit on the periodic table, they make a nice little staircase, makes them really easy to figure out. So let's see here, let's use maybe light blue. So aluminum, gallium, and indium are all +3. Zinc and cadmium are +2. And silver is +1. And you'll be given that information on tests and quizzes and stuff like that. You don't have to memorize that. But you do have to know how to use that information. And what I mean by that is, if you're given a formula like AgCl, you're not going to write silver 1 chloride, you're just going to say silver chloride, because those charges are always the same. And again, it's +1 for silver, +2 for zinc and cadmium, and +3 for aluminum, gallium, and indium. So let's go through a little bit of practice here. You can try some. So let's say I'll give you the name and you give me the formula. Let's start with cobalt 3 phosphate. And remember, phosphate is one of your polyatomic ions. So what do you think the formula for that is going to be? Okay, hopefully you said that since CO is 3 plus, phosphate is 3 minus, and again, that's just something you have to look up in your notes, that we're going to end up with one of each. They cancel without adding any further subscripts, so that our answer would just be COPO4. All right, let's try another one. Again, we'll go name to formula. All right, let's go with copper 1 nitride. What do you think that formula is going to be? Okay, so hopefully you recognize that that Roman numeral 1 means that this is copper with a 1 plus charge. Hopefully you recognize by the ending, the IDE, that this is not nitrate, which is the polyatomic ion that you just learned about, but this is just nitrogen from the periodic table with a -3 charge. Because again, that's the charge that everything in group 15 ends up having. So if I have +1 and -3, then we should end up with 3 coppers and just 1 nitride. All right, let's try one more. Let's go with zinc acetate. Okay, so hopefully, if you didn't remember, you can rewind the video and watch and see that zinc is one that has a constant charge, even though it's a transition metal. So it's in that little staircase that I just outlined for you. All right, it's right here, okay? And it's always +2, just like cadmium below it. It's always +2. So that's why the charge was not given in the name. There was no Roman numeral in between. So it's always +2. And acetate is C2H3O2 with a 1 minus charge. And because zinc is +2 and acetate is -1, I'm going to need 2 acetates. And then again, I'm just going to get rid of my charges and leave the formula. Okay, let's try the other way. Let's give you the formula, see if you can come up with a name. Let's go with FeNO3. What name would that have? Okay, so hopefully you said that in order for nitrate, which is -1, if I have 3 of them, that's -3. So this one single iron atom would have to be +3. And because iron is a transition metal, and it's not one of those 6 elements that are in the staircase that are always the same charge, we have to include the Roman numeral that says what the charge is. So Roman numeral 3. So iron 3 nitrate. The other thing I want to point out is, in addition to that staircase, your S block elements, so these guys over here, those still have predictable charges. They're always +1 for group 1 and +2 for group 2, just like before. So that hasn't changed. So for example, calcium is always going to be +2. So we're not going to use a Roman numeral in the name for like calcium chloride. It's just going to be called calcium chloride. So it's only the transition metals, and it's only the transition metals that are not among the 6 that make up this little staircase over here on the right. Okay, so let's try one more where we are going from formula to name. All right, so let's go with Mn2 SO4 3. Mn2 SO4 3. Okay, so that is going to be manganese 3 sulfate. So where'd I get the 3 from? Well, that's the charge on the manganese, but how did I know that? Well, sulfate is -2. That's just a constant, and you could look that up in your notes. And if I have 3 of them, that's -6. So that means the total on my manganese has to be +6 to cancel that out. And if I have 2 of them, that means each manganese has to be +3. So manganese 3 sulfate.